tackle about definite integral using FTOC or Fundamental Theorem of Calculus. So, are you ready to learn? If yes, let's get started.
The definite integral is a fundamental concept in calculus used to calculate a net under a curve within a given interval. It provides a way to accumulate quantities such as distance traveled, work done, probability distributions over a specific range.
The fundamental theorem of calculus, or FTOC, connects differentiation and integration, giving us a powerful method to evaluate definite integrals. It states that it is continuous and is an antiderivative of. Then, the integral from a to b of x of dx is equals to f of b minus f of a.
This theorem simplifies the computation of definite integral by reducing it to evaluating the antiderivative of upper and lower limits.
So for our first example, we will going to evaluate the definite integral of 4x cubed with respect to x from 2 to 5. So for the first step, we will going to find the antiderivative first. We need to determine the antiderivative of f of x is equals to 4x cubed. To do that, we will use the power rule for integration. So it will be integral of x raised to n with respect to x, and it would be equals x raised to n minus 1 all over n minus 1 plus c. So when we apply it, it would be the integral of 4x cubed with respect to x is equals to 4 multiplied by x raised to 4 all over 4 is equals to x raised to 4. Therefore, the antiderivative of 4x cubed is x raised to 4.
Step 2. Apply the limits. Now is the fundamental theorem of calculus, which states the integral of f of x with respect to x from a to b is equals to f of b minus f of a. Here, f of x is equals to x raised to 4, and we evaluate it at x equals to 5 and x is equals to 2. So f of 5 is equals to 5 raised to 4 is equals to 625, and f of 2 is equals to 2 raised to 4 is equals to 16. Subtracting these values, 625 minus 16 is equals to 609. So the value of the definite integral is 609.
For example 2, we'll evaluate the definite integral of cosine x with respect to x from 0 to pi over 2. Step 1. Find the antiderivative of the integral. Cosine x is a basic trigonometric integral. We recall that the integral of cosine x with respect to x is sine x. So the antiderivative of cosine x is sine x.
Step 2. Apply the limits. Now we apply the limit x is equal to 0 and x is equal to pi over 2. Using the fundamental theorem of the calculus, integral is equal to sine pi over 2 is minus sine 0. From the trigonometry, we know that sine pi over 2 is equal to 1 and sine 0 is equal to 0. So substituting this value, integral is equal to 1 minus 0 is equal to 1. This the value is the definite integral is 1.
Remember that the fundamental theorem of calculus, or FTOC, is a cornerstone of calculus. Connecting the concepts of differentiation and integration, it essentially states that differentiation and integration are inverse operations. Here are some key points about fundamental theorem of calculus. First is, if a function f of x is continuous on the interval and f of x is an antiderivative of f of x, then the definite integral of f of x from a to b is equal to the difference of f of x evaluated at b and a. Next is, if a function f of x is continuous on the interval, then the function f of x, defined as the integral of f of t from a to x, is an antiderivative of f of x. And the significance of fundamental theorem of calculus are: it simplifies the process of calculating definite integrals, eliminating the need for Riemann sums. And it provides a powerful tool for solving problems involving areas, volumes, and other applications of calculus. And last, F-talk establishes a fundamental relationship between differentiation and integration, unifying these concepts within calculus.
So that's all in this video. And I hope you learned something. O, di ba? Basic lang yan.